Hello ladies and gentlemen, hope everyone is doing well today. Today we're taking a look at the first ChemQuest in Unit 12, which is Intro to Acids and Bases. So we start off with some definitions. Up top we have some definitions for our Arrhenius acids and bases. Right below it we have some definitions for our Bronsted-Lowry acids and bases. So I'm sure that you guys can read through them to figure out the difference. But the big difference that I want to highlight is with Arrhenius, it needs to be dissolved in water. Bronsted-Lowry, they can be dissolved in anything. So for questions 1, 2, and 3, use the definitions above to look at the reactions to determine which is the acid and the base. Question 4, I wanted to talk about since it gives you a reaction. So down here, we have carbonic acid H2CO3 reacting with water. So right when you see it reacting with water, that tells us that it's Arrhenius. So we need to look at our Arrhenius definitions. So then we look at the other side of what happened. We see this H3O plus, that means a hydronium ion was added to it because hydronium ions are H plus, and that our carbonic acid is now HCCO3 with a negative charge. That tells us that it lost a hydronium ion because it's now negative. Hydronium ions are positive. So that tells us that our carbonic acid is our acid and our water is our base. So next we come over to the other page. The second page. So it starts off with some information on conjugate acids and bases. So if you read through the problem, read through the information, you find your definitions to answer 5 and 6. For 5 and 6, we know it's a conjugate base because it's always formed by the acid losing the hydronium ion, which is H plus. Conjugate acids are always formed when the base gains a hydronium ion. And remember, we put brackets around it to symbolize concentration. So then in question 7, we are now looking at a couple of examples. It tells us that in question 7 that we're working with acids and that we are adding them with water. Question 8 tells us that we have bases and we're adding that with water. So because we have water, we know that they are Arrhenius definitions, so we can start by adding water. Remember, it tells us that an Arrhenius acid will donate a hydrogen ion to the base. So if it tells us this is an acid, water must be the base, so then that would form H3O plus, because remember, hydronium ions have a positive charge. And then if you're taking away a hydronium ion from the acid, sulfuric acid, it would become HSO4 with a negative charge. The last part of the question tells us to identify the conjugate base. Remember guys, the conjugate base is formed by the acid losing a hydronium ion. So that means over here, because it became HSO4 with a negative charge, that will be the conjugate base because it lost a hydronium ion. We always can tell because it has a negative charge. So you guys can model B and C after A. For AA, it tells us we're working with a base and we have water. So again, we're using our Arrhenius definitions. So that means ammonium, NH3, will gain a proton to become NH4+, plus, and that water is acting as the acid and will lose one to become OH-. Remember, the conjugate acid is formed by the base gaining a hydronium ion, so that would make NH4 plus our conjugate base. You can model B and C after what I did in A. Like always, if you have any questions, please circle them and write them down and ask me when you come to class. Hope everyone has a good day.